Invisibility is definitely one of the worst superpowers. It won't help you avert some big Marvel-level disaster. It won't help you save people in any kind of emergency. And let's face it, it's hard to be seen as inspiring when you can't be seen at all. It's also understandably hard to show invisibility in a positive light, so when a character does have it, like in the H.G. Wells novel, they're more likely to be the villain than the hero. So why talk about invisibility to a room full of scientists and engineers? Because that's our superpower. We take a weird pride in doing our work out of the public eye. We hide our projects under roads or in building foundations. We keep it buried in the ground or submerged in lakes and rivers. We hide our work in forests and in wetlands. We like to walk through nature and visualize the hidden flow of nutrients that only we can see. For us, a good job is if our work fits seamlessly into a larger schedule with as little impact to the public as possible. In the Kipling poem praising our nature, he notes the rest of the world pleasantly sleeping and unaware of what we do. In our jobs, we just focus on the work and do the best we can. But now let's take a look at where our pride in being invisible has gotten us, and that's going to take some audience interaction. I know it's late in the day, but I believe in you. I'm going to ask a few simple A and B questions, and I want you to raise your hand for the one that you agree with. Let's start with the engineers in the room, but for all you bioscience experts, please feel free to lend us a hand. So, we're currently looking at a 3-degree increase in temperature by the end of the century, middle-of-the-road climate projections. Question 1. Do you think that temperature increase means A, less intense rainfall, or B, more intense rainfall? Show of hands, who says less intense? And who says more intense rainfall? Question 2. If rainfall increases, will that change mean we need less land dedicated to stormwater management, or more land dedicated to stormwater management? Show of hands again, who says less? And who says more? Question 3. Now thinking about your clients, your managers, and the public, do you think there's an awareness of having to set aside more valuable land for stormwater, and whether or not that'll make your job easier or harder? Think about the conversations you've had with developers in the past and how they've reacted to those kind of requests. Show of hands, who thinks it'll make their job easier? And who thinks it'll make the job harder? And question 4. That said, is this discussion make you feel better or worse? Now moving on to the biologists and habitat science, certainly haven't forgotten you guys. Engineers, please chime in as well. Question 1. Thinking about things like changing water availability, heat stress, and new invasive species, do you think a 3-degree increase in temperature will mean fewer native species at risk, or more native species at risk? Show of hands, who says fewer? And who says more? Fun fact, I ran this by the biologists at my work, and they surprised me by saying fewer species, because there'd be fewer habitats left around, like cold water streams, and therefore fewer native species left alive to inhabit them. Question 2. In any event, given the added stresses on those species that you need to study, do you think you'll need less time to do your studies, or more time? Show of hands, who says less time? And who thinks they might need more time? Question 3. Thinking again about the developers you work with, your managers, not to mention politicians, do you think there's an understanding or an awareness that these longer studies will mean schedule delays? Who think developers are going to be cool with a delay of a few months to a year? And who thinks they're going to be less than understanding? And in question 4, with that in mind, are you feeling better or are you feeling worse? So, are you starting to feel that little knot of stress? That worry that some of the hidden costs of climate change to your discipline are largely invisible, and how that lack of understanding will impact your work? Maybe you felt something like this before, that certainty of knowledge that people just aren't seeing what you're seeing, and that you have something that people making decisions about climate change need to understand? Well, that's exactly where the stormwater costing idea came from. It was me trying to express my own knot of climate anxiety to people who don't do the work that I do, and trying to make that certainty of knowledge of costs relatable as something we all understand. In this case, money. So the analysis I did to come up with the cost of climate change on stormwater pipes combines 3 bits of information. The first was the Stormwater Network inventory from Mississauga, which, thanks to the city, is a freely available database of all 70,000 pipe networks in Mississauga. The inventory gathers up information for all those pipes, and you can look up information like the oldest pipe, supposedly 1850, I'm not sure if I buy that, the length of all the stormwater sewer systems in Mississauga, which works out to about 3,400 kilometers, enough to go from Toronto to Calgary, or the largest pipe in the city, which is about 9 meters in diameter, about the size of this room. The second bit of information I used to estimate the climate change cost was a pipe catalog, which shows the per meter cost of various stormwater pipes. As a rule, engineers take these material costs, which are already pretty high post-COVID, and double that to estimate the actual cost to get the pipe installed in the ground. I had to make some assumptions to extend the standard catalog because it understandably doesn't run up to those huge pipes I talked about, but fortunately over 90% of the cost is in those smaller pipes, so it worked out. Finally, the third bit of information I used to forecast climate costs for stormwater pipes relates to the saturation vapor pressure of water. The physics tells us that for each 1 degree Celsius increase in temperature, air can hold roughly 7% more water. That's part of why colder air often feels relatively dry compared to warm air. When it comes to climate change, the actual frequency of storms is not guaranteed, but on paper, each degree of increase should allow for 7% more water vapor, which means 7% increase in potential rainfall, and a 7% increase in peak rainfall intensity for design events that we stormwater engineers use to size pipes. The last part means that to keep pace with the larger storms that result from climate change, and crucially, to provide the same level of protection from flooding for people and houses and roads in Mississauga, each degree increase in temperature will require a 7% increase in pipe capacity. That increase in capacity means an increase in size, which means an increase in price across the whole system. So taking these three things together, the result for the city of Mississauga looks like this. Starting with a $3.4 billion cost for the whole current stormwater system, then rising to $3.9 billion with a 1 degree temperature increase, then $4.1 and $4.2 billion with a 2 degree and 3 degree increase, and so forth. That means for our current 3 degree projection, which remember is actually a middle of the road outlook, we're looking at an increase of $800 million in stormwater pipe costs for just Mississauga. This cost again is just the stormwater pipes. It doesn't include land costs or design costs or schedulers or any of the other hundreds of things that go into stormwater design. But even just that number on its own is fairly eye-opening. It's a number that's easy to understand, which is what I wanted in the first place. I've taken that certainty of knowledge that was invisible before, that knot of climate anxiety I've had, and I've made it relatable. And honestly, every time I talk to people about that number, like I am right now, that knot eases a little, and I feel a little better. Invisibility be damned. People making decisions about how to address climate change, and that's everyone, needs to see this from us. And the more I got into this, the more I saw how other engineers and scientists are doing the same thing, making their own certainty of knowledge of climate costs more visible. For instance, there's one group at my work who are looking at how climate change was affecting flood lines, which are sometimes hard to communicate in a static map. And they sat down with the GIS technicians in our office to develop FloodView, which is an augmented reality tool for visualizing flood lines. The tool allows anyone with a phone to download a flood map, then move around their neighborhood, and the phone camera will overlay the different flood levels on what they're seeing. And that's been great for engagement. We had one example where one of the residents saw a flood level in his neighbor's house and said, "Oh, I know that house, that's Jeff's place. He keeps his expensive tools in his garage, and it's bad news for him if it gets flooded like that." And that's great understanding of climate risk, more so than I've ever seen in my 20-odd years of public interaction and public meetings. So there are definitely lots of great ideas to how to reverse that invisibility and make those certainty of knowledge climate costs visible, and show what we're all seeing in our work and make it more relatable to everyone else. So that's the last thing I'm going to ask of you all today. This link goes to Google Doc, and my ask of you is that sometime in the next 3 days, you go to this link and add at least one idea of how to make the climate costs that you see in your discipline more visible. It can be anything. An idea, an image, a one-off discussion you had, a skit, a song, whatever. We're not looking for a lot of detail here. This is just for us to share amongst ourselves. It doesn't even need to be a new idea. It can be one that you already tried and failed miserably, but you still thought was worth sharing. The important thing is that you take a moment and look up from your work and think about how to make your own certainty of knowledge of the cost of climate change more visible, how you can more easily convey that to people, and how you can make your own worry more relatable. Because when it comes to climate change, our invisibility is a superpower we can no longer afford. Thank you.